Next thing that I would like to do with my structure over here is to be able to print its information for debugging purposes. So I can add this member function. I typically add a comment that says operations. So these are the operations that my structure permits, and one of the operations is a void print. Right, print no parameters. It also will be a constant function because it doesn't change anything. So what it does is just prints the values that it stores over here inside. So we can say circle with its center. We can print the center X, and we can print center Y, and we can also print, resize it while I'm typing this, and also print the color, right? I'm sorry, the radius. We'll just skip the color for now. We'll keep the radius. Just say radius equal radius. And this is just for the demonstration's sake, so I'll just add new line. So just an operation to print information about the circle. So to invoke this print operation, we can simply say circle print. Right? We can use it like this, and just quickly run it to make sure that it looks fine. Okay, so here it is. Basically, it prints this information that the circle 10 and 20 apparently is the center of the circle, and the radius is 35. So everything works. I'm able to construct an object, then I'm able to take its size and display, and I'm able to start calling its operations. Of course, I'm also able to construct the circle using a specific constructor that takes 3 parameters. The next step is to create structure named triangle. And I prefer to name my structures with an uppercase character. It's a pretty uniform naming convention for names of structures and classes. Sometimes I also name my structures with a capital S in front of the name, but today we don't need this because our code is pretty simple. So this is a new concept, another primitive here. And we'll just say that this is the ending of the structure right here. And I may be able to say point A, right? So the triangle needs 3 vertices, A, B, C, to be specified on the plane. So just say point ABC. So this is the data members of the triangle. And very likely, let's also add a constructor over here, right? So just like we were constructing a circle by using constructor, just same thing. We need the constructor. Here we'll say triangle constructor will likely require 3 parameters, point A, point E, and point C to be constructed. And of course, we will use again initializer list. I need to spell everything correctly. Right, so we just populate our ABC same way with A initialized with A, B initialized with B, and C initialized with C point. And that's pretty much the end of our constructor. So the rest of the constructor is an empty body. Okay, so this is how we create the triangle. And likewise, in terms of the operations, I want to be consistent, and I would like to be able to add a print operation. But this time, of course, I will say triangle, right? And I will be printing A, X, and bx and by. I'm sorry, ax and ay, and then the same for b and so I need to do this like 3 times. 1, 2, 3, something like this, and this will be B display, and this will be a C display. And if we have something like this in place, and if everything looks more or less okay, we should be able to also create a triangle. Or rather, triangle like this. Triangle. And construct it with points. Let's just go like 2 and 2. Oops, 2 and 2. Then point 3 and 3, just for the sake of demonstration, and point 4, 4, like that, so that we can make it visible. We can print it. And of course, we can also print the size of our triangle, just the same way, the size of the triangle. Triangle is, and size of triangle right here. And this will be bytes, right? So we'll be displaying the bytes. Okay, so let's see how this looks like when we run this program. If not too many mistakes. There was a mistake right here. I'm just simply using that syntax, so this is how it should look like. Okay. And there's a misspelling. Multiple misspellings. Okay. So we run it, and this is what it looks like at this stage, that we're basically creating 2 objects, circle and triangle, 16 bytes and 24 bytes, because now we have like 1, 2, 3, 4, 5, 6 integers that the triangle is using for its memory, because it's made up of 3 points, and each point is occupying 2 integers in space or in memory. And we have these custom like print functions which are capable of displaying internal values of the circle and the triangle. Okay, so this is what we have so far. Now then, I realize one thing, that very likely that the triangle also wants to have a color. Okay, so I'll just like basically copy and paste color and say, okay, I also want the triangle to have a color. And the second I do this, as soon as I begin to copy and paste parts of structure, circle, and copy it inside another structure, it strikes me that there is a commonality. Both circle and triangle have color, which is the common part. So this is just like a very important note to make, because any kind of commonality between classes, functions, any really part of the code should be used once and not duplicated by copying and pasting too much. But we're working on it. So first, let me just do the same thing that I did with the circle. And I said that the triangle also needs a color. And of course here, a comma and color will be initialized. Okay, so the same approach. Now the triangle size will grow by one integer. So if it used to be 24, now it's 28. If I run it, see that now, because triangle has grown with the color 4 more bytes. Now its size is 28 bytes, which includes 3 pairs of points ABC for this triangle, or vertices, and 4 by 4 the color. So altogether 28 bytes. So this is all expected and pretty standard, just use of integers combined together into structures. So this is good. This is fine. Close all running windows over here. Okay. And so this is my next step, is that I begin to realize that this color is shared by both graphical primitives, circle and triangle. If I'd like to use them in my application, graphical primitives somewhere, make them useful. I need to. I would like to, basically, the idea behind it would be that let's make this demonstration over here on our little chart. So this is already something that was constructed. We made the demonstration of a circle, and this time I need to create a similar structure for my triangle. So again, I'll just revert back to boxes. I prefer to draw 3D boxes for my diagrams representing something in computer memory. Oops. So let's finish this work. I will construct this box right here. And of course, once again, this is using X and Y because this is a point. So X and Y. And of course, it's a point. We'll give it its own label. Okay, so, and our triangle will be made up of 3 of these points. So I'll just duplicate this 3 times. Right. And then, of course, the color is also part of our triangle as far as we have it right now. And so altogether, this is the triangle that we're currently using, right? So this is like a box which just encloses everything inside, and this is what it includes. So this is the version of our triangle right now. Right? So, and we can now give it the name that this is a triangle right here. So I'll just type it in. When we construct it, this is what it looks like. And this is, of course, the code for it. 3 points, each single one of them having 2 integers for x and y positions inside the in some sort of like a 2-dimensional plane, and then 3 points and the color. So this is the circle and this is the triangle. Okay, so the next step is that we recognize that the color being duplicated twice. You know, on one hand, this may seem like not a very important duplication, but since we also recognize that both of the objects are sort of representing conceptually graphical primitives that we'd like to use to construct some kind of drawing, the commonality among them is very important. And so the commonality can be expressed through C++ inheritance. And so instead of copying and pasting, this copying and pasting of the color from here, from the circle to the triangle, can be delegated to the compiler. We can use C++ compiler to share values like data members and also functions between these primitives. So that's our next stage. We're going to make this progression and start using inheritance to describe common parts and to make it usable in our little demo application.